Dude, I can't wait to publish this 4-hour video essay about the ethics of eating the crust. This is gonna be so... Man, this computer sucks. I mean, it's not even real. It's just a pressure plate and a painting. Guess I should just get a new one.
Hello, thank you for calling Best Buy. This is Testable speaking. How may I help you?
Yeah, let me get a RGB gaming PC with a Ryzen 9 and a 4090 would be nice.
Sorry man, we're all out.
What? What do you mean you're all out?
Linus Tech Tips bought up our whole supply. We're not gonna have any computers coming until probably next year.
Next year? Are you serious? Well, I guess it's time to take matters into my own hands.
Hey everyone, it's your favorite funny Minecrafter here, SpeedyCube64, and if you're wondering where I was for the past 9 months, here's your answer.
Now, the first question that you probably have is, why? What would possibly motivate someone to do such the prospect of views a monumental task? Well, it all started because of my computer engineering classes. Throughout my sophomore year, I learned about basic digital logic and how it can be built upon to create fully functional CPUs, which I thought was super cool. And then I realized something. I'd been playing Minecraft for 9 years by that point, and not once did I think about getting into Redstone. But it turns out that Redstone and digital logic are basically the same thing. This field of study that I was so fascinated with was right there the whole time.
As you might expect, the goal I set for myself to build an entire computer in survival Minecraft was not going to be easy. In fact, this was so daunting of a project that I actually conceptualized it in March of last year and didn't even start it until 10 months later. But I just had to start somewhere. My first step was figuring out what I actually wanted my computer to do. How much data would it store? What accessories would it include? And what instructions would it be capable of carrying out?
Well, I spent a couple hours making this spreadsheet. I would be lying if I told you I didn't pick some of these specs at random, but I could always change these later if I wanted to. Now, I know this probably looks confusing, but you don't really need to understand it. This video is mostly focused on, actually doing the thing I said I did in the title.
I will be explaining a few things as I go so you can at least have an understanding of what I'm trying to accomplish, but if you really want to know how the computer works, I have a supplementary video in the description that you can watch. That video goes over how each component works with examples and even shows you how to program it yourself. But for now, let's move on to the next step, drawing the diagrams. This was a crucial step in the process just because it allowed me to make sure that I hadn't completely forgotten what I learned in class. Now, if this was linear algebra, then I would have been shit out of luck. But in this case, I actually remembered a fair bit about how a CPU works. By the end of it all, I knew exactly which components I needed to build. But before I jump right into the survival world to build them, I have a question for you. Have you ever been building a house in your survival world only to realize that the whole thing was like a block off and then you had to tear the whole thing down and build it again? Now imagine that, but instead of building a house, you're building this thing. That wouldn't be very fun, would it? That's why I decided to use creative mode and world edit to plan the computer before actually building it in survival. So, in other words, I actually built the computer twice. This was actually my first time using world edit, and it was an absolute game changer being able to copy and paste huge sections of blocks with only a few keystrokes. But even with that to my advantage, it was still a lot harder than I expected. You see, when you're drawing a diagram, you can just sort of slap down the components without really worrying about where they fit. If you're lazy and you don't feel like drawing these lines that go from here to here, well, you don't have to. Even when you're making real hardware using code, you can still just sort of put your components down without a care in the world as to where they're actually gonna go. That's the synthesizer's job, not mine. But when you're building with Redstone, there's no such thing as synthesis or implementation. You have to figure out where each component goes, and you have to place the wires down connecting them all together. Let's take this problem for instance. How would you have one set of wires cross another set of wires without them interfering with each other? This is something I literally never had to think about until I started this project, and I was stumped. Sure, I could just take the entire thing and move it up and down like this, but that took up way too much space. Luckily, I happened to be streaming when I encountered this problem, so one of my viewers came to the rescue and showed me this screenshot. It was perfect. All I had to do was lift this set of wires one block up, and then use repeaters to pass these signals through the blocks without affecting what's on top. And that's just one of the many challenges I faced when transferring my hardware design skills into Redstone. And speaking of learning redstone, this project probably wouldn't have happened if it wasn't for the legend himself, Matt Batwings. Both his old and new logical redstone series were super helpful to me throughout the design process. Anyway, here's a prototype I made. It might seem like a complete mess, but it still took a whole 32 hours to make. Again, I won't be able to explain all this lest this video become boring hell, but I can give you a quick rundown. Here, we have the arithmetic logic unit, which does all the math and bitwise logic operations, and here's the register file, which is basically the computer's short-term memory with a capacity of 8 bytes. These two components communicate with each other to carry out the instructions in the program. For example, you might see an instruction that goes like add 201. This would tell the ALU to take the numbers from slot 0 and slot 1 of the register file, add them together, and then store the result into slot 2. Aside from those two components, we also have the instruction ROM, which holds all the code in the program, and in front of it, the program counter, which goes through each line of code in the instruction ROM one by one and also handles loops with special instructions such as jump if 0. There's also a clock signal synchronizing the whole thing. You might have used these redstone clocks to open and close doors repeatedly to annoy people, but this is also an essential part of any CPU. The clock signal is hooked up to a few different parts, including the registers and the program counter, so the speed at which the clock turns on and off determines how fast the computer can get through a program. This is why you see super fast clock speeds advertised in the newest CPUs. Do you want to know how fast this thing's clock speed is? 0.1 Hertz. This means that it takes a whole 10 seconds for the computer to execute a single line in the program. The good news is that we can use this mod called Carpet to make the game process the redstone faster and make these programs actually run in a reasonable amount of time. So we have a workaround, for now. Anyway, I've hooked up a 7-segment display to one of the registers so that you can see what it's actually doing. Right now it's running a simple program that just counts up to 10, which shows up as an A here, counts back down to 0, and repeats the process. So now that I have this working, I can build it in survival, right? Wrong. First of all, a lot of these components can be made more optimal. The looping logic? Bam, it no longer looks like a 5-year-old made it. The register file? It just got 32% smaller. The ALU in particular went under a lot of scrutiny. It took 3 different designs before I finally made something I liked, resulting in a whopping 67% decrease in volume and 42% decrease in the amount of redstone it takes to build it. It's still not nearly the most optimized design out there, but the important thing is that I built it and I understand it, so I'll have an easier time debugging it when something goes wrong. But aside from that, this prototype just doesn't do enough things. What I have right here is basically the bare minimum for a CPU. I guess you could technically call it a computer on its own, but usually you're talking about more than just the CPU. Where's the keyboard? Where's the mouse? Where's the triple monitor setup? Okay, maybe I won't be doing all that, but this thing does need some sort of input and output, so it's time to go ahead and make those. Here's a device that lets you type a number in decimal. So 4 enter 5 enter gives you 45. Here's a device that looks like a controller and is also made of dirt because I was kind of running out of blocks to use. Here's a device that generates a random number every clock cycle, because it wouldn't really be a proper computer if you couldn't get rolled on RNG. Here's a display that can show a number in decimal. Here's a display that can show both numbers and letters. Here's a screen with an ultra high resolution of 8 pixels by 8 pixels. You can plot a point, erase a point, or fill the whole screen up. All of those inputs and outputs are hooked up to this dedicated WAM with a capacity of 32 bytes. I mean 16, I realized I didn't actually need that much. Now all it took was another whole day of wiring together all these components, and there we have it, the actual redstone computer. The idea behind the layout is that you can stand here and have access to all the inputs and then sort of be able to see all the outputs too. I put some more programs on it and they work just fine. I'll save those for later in the video, but here's one of them, just so you don't think I'm sus for not showing you anything. I know I kind of sped through all that, but it still took me a whole 100 hours just to get to this point. That's 3 whole 100 days Minecraft videos worth of time. Again, if you want to know more of the technical details of how this computer works, you can check out the supplementary video in the description. But the question remains, how much redstone will I need to build this? But wait a second, that doesn't count any of the repeaters, or the comparators, or the torches. Even the target blocks and redstone lamps have to be taken into consideration. Plugging it all into a giant formula, we get a grand total of 41,564 redstone, otherwise known as 3 entire chests of redstone blocks. This is gonna take a while. But it has to be done, so let's just move on to the survival world. We have a swamp spawn with taiga. Very interesting. This is the first world I'm playing. This is the one. This world will have a redstone computer in it somewhere. So let's get started. Wow. Oh. There we go. Oh. As you can see, the beginning of this world followed the typical zoomer progression of beating the game to obtain the elytra and other endgame items. But what was the actual game plan here? How was I going to get 41,000 redstone? Well, mining it all underground would take way too long, so I had to find another way. Luckily, redstone can also be dropped from witches, which can be spawned during raids. So the first step was to get a bunch of observers, pistons, and other various redstone doohickeys. This meant taking another trip underground to get all the minerals I needed.
Heading out to the mine, 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 to the mine.
Luckily, I spawned in a swamp, so getting slime for sticky pistons was no problem. But the next step was a different story. In the materials list were 3.5 stacks of scaffolding, which meant I needed to go to a bamboo jungle. What followed was a whole 30 minutes of tediously flying as fast as I could while still having the chunks around me loaded. But it was all over when over 15,000 blocks out,
Oh, yes, there we go.
I could finally make my way down into the jungle to get my first piece of bamboo.
Oh. Huh. Oh! Okay. Here it was. Nope, don't blow up my stuff, please. It's no good. Nope. Fucking don't blow up my stuff. You better not.
The good news is that everything else was easy by comparison. I just had to get a couple stacks of sand, look up the best Y level for coal to smelt the sand, and then make a short trip to the nether to get some more quartz. And finally, I needed to create the perfect sword for the job, with looting 3 and sweeping edge 3, which let me actually use the farm and get the most drops possible.
3. Oh, wait. How is this? This is 24, but this is 3. How do you explain that? Alright, anyway, yeah.
The farm I'm building is called the Practical Stacking Raid Farm, designed by IanX04. I'm glad I did this challenge when I did, because the 1.21 update completely broke this farm. I mean, why the hell do you need a bad omen potion to start a raid? Could America not declare war until Al-Qaeda drank the 9/11? Anyway, despite the farm's complex mechanics that I still don't fully understand, the tutorial was actually pretty easy to follow. Construction was going smoothly, and it was only a matter of time until
Oh my god. What else? Oh my god, shut the fuck up. Stop trying to hit me. No.
Oh no, I can't. He just keeps winning. He's winning. I don't know what to do. I need one more good hit on him. I mean, he's dead, but I can't fucking do it. I can't get it. There we go. That took way too longer than it needed to. Okay. Fortunately, I was able to get back all my supplies and finish building the raid farm. Bye-bye. But there was one item that got lost in the fire, and that was the precious Looting 3 Sweeping Edge 3 Diamond Sword. In order to get that back, I had to make an Enderman farm for XP. And you might be thinking I looked up a design that was actually good, but no, I just pulled the design out of my ass and it sucked balls as a result. So if a job interviewer ever asks me to reflect on a failure, this is what I'll be bringing up. After using this Enderman farm that was more empty than a movie theater in 2020, I finally got my sword back. And it was time for the most exciting part of the run thus far.
You are a great person, but things are moving a little too fast.
First of all, you might be wondering why I'm not just using an auto clicker, and that's because I'm not chief. But besides that, although this process was quite boring, I was finally making significant progress towards having all the materials I needed to make the redstone computer. This farm produces 5,300 redstone per hour, meaning that it was going to take 8 hours of clicking the armor stand over and over again to get all the redstone I needed. And I was totally fine with that. It wasn't a perfect solution, but it was way better than spending maybe hundreds of hours mining underground. But after my first clicking session, I came across a technique that would change everything. Enter void trading. This is a technique that uses the end gateway to unload a villager while you have the GUI open and finish the trade while he's unloaded. This makes the villager forget that you traded with him, so he never runs out of stock. Doing this with the cleric, you can get 24 redstone every 3 seconds. So it turns out that all these emeralds that the raid farm also happens to produce are suddenly useful now. Side note, you'll never guess what the 1.21 update did with this trick. I did some rough calculations and it turned out that taking void trading into account, I only needed to use the raid farm for like 1 hour instead of the original 8. Not only would this give me enough emeralds to buy all the redstone, but I could also trade with the mason villager for blocks, which I also needed in enormous quantities. If you were wondering earlier why the final build has such an abundance of chiseled stone bricks, well, now you have your answer. So all it took was a few more minutes of mindless clicking and I was ready for the next step of my adventure. I packed up all my emeralds, took all the shulker boxes I had, and started making my way, and bringing the villagers with me, to the outer end. There's a zombie there. Uh-oh, I think I gotta intervene. Oh my god, what? What happened? Where's my guy? Oh, that also ended up taking longer than it needed to. But now it was time for the second most exciting part of the challenge. After what felt like forever, I finally had everything I needed to build my redstone computer. Just kidding. There were a few miscellaneous items I still needed to get. Don't worry, I'll make it quick. First, a bunch of quartz for comparators. Next, a bunch of wood for barrels, redstone torches, and the vast array of chests I needed to store all my stuff. And last but not least, another 13,000 stone. But once that was all over with, after 22 hours of
after 23 hours of gameplay in the survival world, it was time to get started on the build for real. So, looking at the creative build, it's pretty obvious which part I decided to make first. I'm of course talking about this part right here. I decided to build the computer on a large platform in the ocean, because why would I bother leveling out a giant section of ground when I can just void trade for a couple extra 1,000 blocks?
Alright, all that needs to be filled.
It wasn't until I started filling in this platform that the true magnitude of what I was doing dawned on me. Entire inventories of blocks were being used not even to build the components, but the mere platform that the components would be on, and my finger was not happy about it. But again, it just had to be done. I'd already gotten all the resources, there was no going back. At least this part had a pretty cool ending.
Oh my god, that was so satisfying.
As the night went on, I decided to start building my first actual component. And if I thought the platform was tedious, then I was in for a treat. This is a slab tower. It uses a bunch of top slabs in an alternating pattern to carry a redstone signal directly upwards. These slab towers are an important part of almost every single component of the computer. In creative mode, you can just make the first 2 slabs and / stack to finish the rest. But in survival, well, imagine a fish on land flopping around trying to get somewhere. That's basically how I felt while building this.
Alright.
It eventually got better though. I realized over the next couple days that my building techniques were quite inefficient. I moved my Haste 2 beacon over to the main platform, I actually started using shulker boxes to store my supplies, and my stream chat showed me a less headache-inducing way of building the slab towers. But the most important change was one that, as a speedrunner, I probably should have realized a lot earlier. With a bit of messing around, I was able to get my creative world and my survival world on screen at the same time with convenient hotkeys to switch between the two. And with all these newfound boosts in productivity, I finally felt like I was getting somewhere.
Pirates on
A boat. Pirates on a boat. Pirates on a fucking boat. Pirates on a boat. Pirates on a boat. Pirates on a boat.
Now, as much as I would like to say, and then I built every component of the redstone computer, the end, that's unfortunately not what happened. Building the entire computer at once would be very unwise. If something went wrong, how would I know which one of my 5,000 components was responsible for it? Instead, I split the survival build into 3 sections, each with its own test program to run. And when I got the final program to work, then I would finally be done with the project. Well, except for editing the video. Let's just say that's taking a bit longer than expected. But right now, I was coming up on my first milestone, the Fibonacci sequence. This is a pattern of numbers where you obtain the next number by adding the last 2 numbers together. Showing the Fibonacci sequence was a pretty simple program with only 10 lines of code, and it would be perfect for testing out the core components of the CPU. But wait a second, how was I even going to program this thing in the first place? My code here is written as a series of assembly instructions, but I can't just copy this in when I'm dealing with redstone signals that can only be on or off. Instead, I have to convert this into machine code, which is literally just a bunch of ones and zeros. You can't get any more low level than that. When I was working on the creative build, I was actually doing all this conversion by hand, and I did not want to do that again. So I spent a couple hours in C++ writing an assembler program to do it for me. I know there's a stereotype of programmers spending hours to make something that saves them minutes, but this assembler started saving me time pretty much immediately. It was great. Once I had my sequence of ones and zeros figured out, I put my Fibonacci program into the instruction ROM, placing a repeater down when there was a 1 and leaving the space blank when there was a 0. After repeating that 100 or so times, I put some lamps on one of the registers to see the output, and I was now ready to test it out. Would it work as I expected it to? Let's see. Now, I know what you might be thinking right now. Are you really so bad at programming that nothing's happening? Surprisingly, no. Do you remember what I said earlier about this computer's clock speed? It takes a whole 10 seconds for the computer to execute a single line in the program. The good news is that we can use this mod called Carpet to make the game process the redstone faster. Yeah, I'm not using that mod in the survival world. I consider that to be a bit too much. So, as if debugging wasn't bad enough already, I had to debug a program where it took a whole minute just to go from one Fibonacci number to the next. And let's just say there was quite a bit of debugging to be done. Okay, I'm gonna let this keep running. I'm gonna go get some water, and you tell me if the 8 shows up.
1 minute, 37 seconds later.
You bastard, it's still at 5! If it's taking this register, and adding them, you should not get a 3. You should get a 2. If the 3 is coming from here, and the 1 is coming from here, but now it's taking the reg 7 as, so it should have moved the 0 to register 0. But it didn't. So register A is the problem here. This torch is off. Oh wait, no, this is B. This is A. Wait, hold on, I'm so fucking confused. It wasn't until I spent nearly a whole hour looking around the computer for mistakes that I decided to change my approach. I finally started doing what a real debugger does and implemented a way to step through the program one line at a time by disconnecting it from the clock signal. So we have our 5 and our 5 going into this XOR gate. So if we look, okay, so this one's good on the bottom. This one's good on the bottom. This one's not good at the top. This repeater is not on for some reason. Why? I'm getting somewhere, I think. I'm getting closer to the solution. I think the freezing the computer was a good idea, definitely. Oh my god. Look, it's a repeater problem. Okay, it got cleared, that's good. We have the 0 to start with. We got to the 1. Yep. I see 5. I see 5. I see 5. I see the 8. It's here. Oh, I see the 13 coming in on the dust. Yes, dude. 21. Give me the 21, dude. It's there. It's a 21. There it is. There's the 34. Our thing works, dude. What? Huh? Oh no. This stream sucks balls, dude.
The next day.
Okay. Well, I think I see the problem. Alright, so we got a 1 there. That's good. So we started with a 0. We have a 1 as well. Alright, we got a 2. We got a 2. Also, there's the 34. I like that. It's 55, right? 110111. Okay, we're good. Wait, what is that? That's 89, right? 0101. I'm at 144 now. Okay, there's the 233. And so now what it should do... Yep! There we go! There we go, guys! This fucking program works now, finally. Took long enough. You know, I'm starting to see a theme throughout this challenge of things taking way longer than they need to. But whatever. I was finally done with my first program, and it was time to build the next few components. The RAM, the inputs, and the number display. I don't really have that much to say about it, so here's another montage. After building and testing all the new components, I was now ready to put in my second program, the Multiplier. If you're an astute viewer, you might have realized that out of all the operations I listed for the ALU, multiplication wasn't one of them. Multipliers tend to be big and slow, not only in Minecraft but in the real world as well. So instead, we can take advantage of the fact that multiplication is just repeated addition. With this program, I could test out the new peripherals by entering the two factors on the inputs and seeing the result pop up on the number display. This program used 22 lines of code, and it took about 20 minutes to put into memory.
I'm gonna do 4 and 1. That's gonna put 5 there. So if I wait long enough, eventually 5 will show up there.
As you might have expected, the number 5 did not, in fact, come up on the display. The debugging process was about the same for this one. I went through the program one line at a time and just looked around until I found the problem. And let's just say I ended up finding quite a few problems. There was one part where the redstone ran out of signal strength, there was one section of wires that I straight up forgot to include, and it turned out I built the flag logic all wrong too. What was I on when I was building this thing? Oh yeah, and you can't forget about the classic repeater problem.
Wait, why is that repeater does not look like it's in the right spot. Bruh.
But after 2 hours of messing around, my multiplier program finally started doing what it was supposed to. I punched in the first factor, and it showed up. Then I punched in the second factor, and it also showed up. Then I just sat there and went crazy on my cube as usual as I waited for the result.
Oh my god, yes, dude. We did it. 8 times 7 is 56.
And you just know my immature ass had to test out 23 times 3 as well.
Come on, man. Give me the result. Yes! It works, dude.
At this point, I was so close to finishing this computer that I could almost taste it. I only had 2 more components to build before I could run my final program. Sure, they weren't the easiest components, but I knew I could crank them out in a couple days. You already know how this goes. Cue the time lapse. Once I got these last 2 components built and individually tested, I was at my 3rd and final milestone, Hello World. This is like the quintessential computer program. Pretty much any programming tutorial you look up will start with the Hello World program or some variation of it, so it was pretty important for my Redstone computer to be able to do this. My version of the program would print the 2 words on the letter display and then print a smiley face on the screen. This ended up taking almost the entire capacity of the instruction ROM with 62 lines of code, and I spent nearly 40 minutes just putting it all down. I built a platform to see the outputs better, and almost immediately I got something on the letter display, but as you can see it wasn't quite right. You might think that this program would be the worst one to debug, but it actually only took me about an hour and a half to figure out everything wrong with it. I guess progressing through those 3 milestone programs turned me into a pro at debugging Redstone. I added some wiring that let me go back to an earlier point in the code, I added an option to force clear the screen midway through the program, and I was going line by line in the code so often that I added a switch to go between normal mode and debug mode. With these new debugging techniques, I slowly but surely found all the tiny little mistakes that stopped my program from working, including yet another repeater problem.
Oh, this needs to be like this because it's a pulse generator. It can't have a 1-tick pulse. There we go, clear as now, perfect.
With all these mistakes flattened out, well, there was really only one thing left to do.
Alright, let's reset it now. This is for all the marbles. It's not really, but, you know. Alright, we got the screen cleared, pretty good. Got the H. It's happening. This is the run.
41,000 redstone, 100 hours of testing, 23 hours of getting resources, 75 hours of building, 1 terabyte of recordings, and 4 months of my life. As you can see, this project took a lot from me. So while I show you the final result, I'd like to ask you for one small favor in return. Hit it, Red Penguin.
Time
Time keeps moving like a highway truck. I haven't uploaded in about 9 months. Never used to struggle with getting sucked, but when I'm pushing 30,000 it ain't going up. I'm losing touch, I'm desperate. I need a few more subs, just a few more subs. I built this computer in survival mode. I already built it in creative mode. 10,000 reasons why I get watch time, but it'll only take one for you to unsubscribe. But I can't help but think this one will move along. Yeah, I'll catch right on. No. Between the blocks, my redstone is a mess of a catastrophe. The nights I spent debugging, wiring every single time. I'm sure you know this channel isn't everything I am. So many dumb responsibilities that make a man. But I can see why you won't subscribe to me, 'cause you don't need me, not the way I need you. Even still, this build is pretty cool. ALU instruction ROM, it's even water cool. But the hours in this world, pushing 64, and then even more. I might need another month to get this off the ground, but I don't need my foreign bid to drag my channel down. I've had enough of you clicking off my stuff, 'cause you don't need me, not the way I need you. I'm losing touch, I'm desperate. I need a few more subs, just a few more subs.
It's over. It's over. It's over, dude.
And then I spent 5 more months editing that entire experience into a 40-minute video. I could also go into a bunch of detail on what that took, but I think I'll save that for the supplementary video. Just know that this was by far my biggest and most grueling project ever, so again, I'd highly appreciate it if you subscribed. My next video won't quite be as crazy as this one, but I can assure you that it will still be legendary. Thanks to everyone listed here in the credits, thank you so much for watching, and as always, stay speedy. Peace.